first question I was asked about this project is we had considered geothermal and why we had considered geothermal, and actually how did we get to the project. We did the fire station for the town of Newfane, which is located about a mile down the road, and this was the old fire station. It was one of the ugliest buildings in town, and we kind of changed it a little bit. We bid the project and unfortunately came in $500,000 high. Timing was absolutely terrible for bidding it. We reworked the project, took some parts of it out of it, and took a look at the heating system because I met Tom Varga from Mitsubishi, and he brought up the heating system that we have now, the variable refrigerant flow. And when we looked at that, we said that would be a lot better. We dropped some heavy electrical. We dropped a complete electrical panel. We didn't have to worry about the pumps. The heat's free with a geothermal system. However, you have to pay for the electricity to operate the pumps and the systems that go with it. Once we rebid the job, it came in $500,000 lower than what we had anticipated. There was $1 million swing in it, and that turned out to be really nice for the town. Initially, we used geothermal. We had designed the building to be operating on the geothermal system. It had initially had rooftop units when it was the fire station. When we bid the project and it came in high, we took a look at everything in the building. And I had met Tom Varga at the time and learned about Mitsubishi. When we looked at the geothermal system, we realized that, yes, the heat's free, but you have to pay for the electricity to operate the pumps. And they're not little pumps because you're moving a lot of water a long way. When you add that together with the electrical panel that you have to have for the additional electrical supply, it turns out that's not a free system. It's a very expensive system. The initial cost for the pumps, the initial cost for the loop system, the initial excavations, the backfill. We were going to use a slinky system, which is about 8 foot deep in the ground, and it's a coil instead of the well. If we'd use the well, you have to drill the well. You've got to pump water roughly 600 feet up and down. It sounds really good. However, you need to consider all the effects of a geothermal system. The system as installed right now has operated fantastically. And I say that because it's kept our energy costs low. It has provided a wide diversity of temperature controls for different rooms all at the same time, which makes a lot of people happy who weren't happy previously because they had one temperature period to operate with. This room we're in can be turned down during the week. It can be turned up when it's needed for a meeting. It's all computerized control. Tim can control it. Tim, the town supervisor, can control it from his house on his computer there. The staff can control it from their offices. Everybody's extremely satisfied with the way the system operated. The building serves as a town hall and a community center for the town. It's also an emergency preparedness center. It's capable of taking a large number of townspeople in if there's a disaster here. But the really neat thing about the system is because of the dual uses and the different functions within the town hall and within the community center, you can control the heating and cooling dramatically so that the lost energy that you would normally have with a standard heating system, which heated the whole building or cooled the whole building with very little difference between them, between different spaces. This one, Tim can shut down or at least turn down the temperatures in the community center when it's not in use. He can program it so that it automatically warms up just prior to the use of the community center and set it for whatever it needs to do for the number of people that are in there. The room that we're in right now is the town hall, which operates maybe 2 times a week. The temperature can be turned down in here, saving energy in this space, and it's a fairly large space. It also can be set to come back on just prior to the start of a meeting, bring it up to temperature so that or down to temperature in the summer, so that it doesn't waste any energy. The other really neat thing for the employees in the town hall is that each of the individual rooms is temperature controlled so that those that want it warm, have it warm. Those that want it cooler, have it cooler. We coupled that with solar voltaic on the roof of this project. Altogether, there were some initial numbers of electric bills of $400 a month, and this is a 13,000 square foot building that operates pretty much all the time. There's a community center involved in it. There's the town hall, this meeting room that we're in right now. And some of the really neat things about it is this meeting room gets used a couple times a week. So they can control the temperature in here, keeping it moderate at best, and then when they need it, it automatically kicks up. The community center operates mostly in the evening, but there's some things happening once in a while in the daytime. Tim has control of that and can have it programmed to turn on when they need it and turn off when they don't need it, keeping moderate temperatures in there. Originally, we had a monitor in the front lobby that gave you the energy savings. You know, when you spend this kind of money and the town takes a look at it, you can, when they walk in and they can look at something like that and say, geez, we saved this much money, it makes a big feather in Tim's cap as a politician. But it also shows that the system, it may have been expensive from the standpoint of a rooftop unit versus the Mitsubishi system, but it sure as hell blew away the doubts about it.
So we constructed the building, we put the system in, and since then, I have to say that we have been extremely happy with the system. We're zoned into 4 zones. Each zone can control their own temperature. We're either on heat or cooling, but we have 9 women who work here. And in my opinion, the system was worth $1 million to keep them happy.
Tim had a situation to begin with where his staff, one of the girls was from Arizona, another one was a local woman, and they didn't like the same temperature. That was resolved immediately, and Tim had harmony in the house. In the original town hall, there were a lot of complaints about the fact there was just one rooftop unit and the heat was the heat and the cold was the cold. With this system, the people that want it warmer can have it warmer. The people that want it cooler can have it cooler. The rooms that don't need heat aren't being used. They're not on the system at that time. It just turned out to be fantastic as a heating system for this type of a project. It shows the energy consumption that is coming out of the solar. There's no question, he saved money. This is a lot cheaper to operate than what he operated in his town hall previously.
Energy-wise, we don't have a firm grip on it because we do have solar on this building, but we know it's energy efficient. We know it's much more energy efficient than what geothermal is going to be.
It wasn't recognized when we first put it in for the energy efficiency of it. It's now getting credit for that. That's one of the things that's going to make this catch on really well. One of the things that we do as Americans is we kind of stick with what we have. We've had oil heat and gas heat and propane heat. Those systems are like cavemen heating. And I don't mean that derogatorily to the industry, but basically it's an open flame heating air. And then you force that air through the building. What we're doing here is we are extracting heat from the air, piping it to a manifold, and the manifold distributes it to the different areas, and we're able to control the heat individually in each of the rooms. That's a lot better than using a forced air system where we got one temperature, we're blowing it throughout the building. If you like it, that's cool. If you don't like it, tough. This system allows us to set the temperatures throughout the building and give us a nice, happy work environment. It's got a lot of advantages over a regular heating system, a conventional heating system in America. I know in Asia and in Europe it's used extensively, and probably the day's coming soon where it'll be used a lot more.